Okay, so our last topic we got to cover is going to be polar coordinates. So think about on the Earth. If I wanted to tell somebody a location on Earth, say we're here in Florida, and I wanted to get them over to someplace maybe in England, I wouldn't tell them, well, sail your boat 500 miles east and then 700 miles north. I could, that would get you there. But the way we tend to give locations on Earth is longitude and latitude. So we would tell them the angle from the North Pole to get our latitude, some angle down, and then we got our prime meridian here. We would give some angle over from the prime meridian and give our location that way in terms of two angles. So the point is there's more than one way to give a location. Same thing in our Cartesian coordinate system. If I've got some point here, let's call it point XY. So that means you go over some distance X, up some distance Y from the origin. Another way I could do that is say, okay, start by facing along the X-axis, rotate some angle theta here from the X-axis. So theta is fixed here. It's the angle from the X-axis, and then walk out straight some distance R. That would be a different way to give this location. Now we tend to write polar coordinates R comma theta, even though we actually do the process the other way. We do the angle first and then we do the distance. For example, the point 530 degrees means you start by facing along the x-axis, rotate 30 degrees. So now you're facing that direction, and now walk out 5 units. So 1, 2, 3, 4, 5. That would be the point 530. Now the thing with Cartesian coordinates, if I give you an XY, there's only one way to represent that point, XY. In Cartesian or in polar, there's more than one way to represent the same location. I could instead say rotate all the way around. Imagine sitting in a spinning chair and you spin all the way around 360 degrees plus another 30 degrees. You're still facing the same direction, and now walk out 5 units. So I could also write that point 390 degrees. Same point. In polar coordinates, there's more than one way to get to the same location. Or I could say, no, let's do this. Let's rotate backwards 330 degrees in the negative direction. Remember, this is a positive rotation, this is negative, and walk out 5 units. So another way to say that same point is 5 negative 330 degrees, all the same point. Or we could do this, and this will look weird, but mathematically we allow this. I could say, I want you to rotate, we'll do it as a positive, 210 degrees. See, you're facing that direction. You're facing down, but I want you to walk backwards. So facing that way, walk backwards 5 units. The way we take care of that is we allow R to be negative. So you're facing 30 degrees below the negative x-axis. You walk backwards 5 units. You still land right there. Same spot. Okay, so that's the first interesting thing with polar coordinates is there's more than one way. There are an infinite number of ways to write the same point, and they're all equivalent. Now, how do we go back and forth between these two? How do we go back and forth between Cartesian and polar? We just use trig. First off, this is a right triangle. So x squared plus y squared has to equal r squared. And this angle here, we just use trig. We could say, for example, tangent of theta will be y over x. So if we know the x's and the y's, we could find the r's and the thetas. So this is to go from Cartesian into polar, or we could go the other way. If I know the polar, I could go back to Cartesian just by using trig. Look at this right triangle here. Sine of theta would be y over r. So y would be r sine theta. And x would be r cosine theta. So this is to go from polar back into Cartesian. Okay, so let's practice that. This way always works. This is the easiest version. This is really simple. Here we got to do a little extra work. So easy, harder. Okay, so let's start with the easy. Let's say I want to convert. Oh, let's use that point we had a minute ago. 530 degrees into Cartesian. Well, x equals r cosine theta. Y equals r sine theta. We just get our calculators out. This would be 5 times cosine of 30 degrees, 5 sine of 30 degrees. I know sine of 30, that one will be easy. That's a half. So this I can do in my head is 2.5. I'm gonna have to get my calculator out to do the other one. I mean, we could do an exact answer, but we're just gonna round this. Make sure you're in degree mode here if the angle is given in degrees. It's a common mistake, especially on the final. You want to be really careful. Degree mode sometimes, radian mode sometimes. For the most part though, if you're using the calculator, you're going to be in degree mode most of the time. Okay, I got 4.33. So this point is the point 4.33 comma 2.5 in x and y. So there's r theta, x and y.